Okay, so number 3 says a paint can is in the shape of a right circular cylinder. The volume of the paint can is 600 pi cubic inches and its altitude is 12 inches. We want to find the radius in inches of the base of the paint can. We want to express our answer first to the nearest tenth and also in simplest radical form. Okay, so what shape are we talking about? We're talking about a right circular cylinder. And if you look at your reference sheet, you should see the volume of a cylinder is pi r squared h. Okay, so they give you the volume is 600 pi, and the altitude, or another word for altitude, is height, is 12 inches. So we're going to take those two numbers and substitute it into our formula. So where you see the V for volume, you're going to replace it with 600 pi. Pi r squared. R is what we're looking for, and the H, which is the height, is what they told us the altitude is. We substitute them in, and then we're going to divide by 12 pi because we want to isolate that variable r. So then we have r squared is equal to 50. We want it to the nearest tenth. So for the nearest tenth, we're going to take the square root of it, and when you put that into your calculator, you get 7.07, and that rounds to 7.1 inches. And then it also said they want you to express it in simplest radical form. So from r squared equals 50, you have to break 50 into a perfect square and a non-perfect square. So that's 25 times 2. The square root of 25 is 5, and you're left with radical 2. So either 7.1 inches or 5 radical 2 inches. If you type 5 radical 2 into your calculator, you're going to get the 7.07. So that should prove that it matches. We went over these next 3 questions in class. So number 4, when you take the cross-section of a hemisphere, remember all the cross-sections are circles, so a half of a circle should look like choice 2. Number 5, our answer is 3. Off the bat, we could get rid of choice 1 because we know if we cut a cube, we should have at least a cube. So that would limit our answer from choice 1. Can't be true. Choice 2 would be correct if we didn't have that cylinder cut out up top. This one right here, choice 4, would be the answer if it was cut parallel, which would be this way, because remember, anything cut parallel to the base would be the shape of the base. That leaves us with choice 3, and these dotted lines represent that cut out of a cylinder. Oops, wrong way. And then 5, we also said if we treated our revolution line as an axis of symmetry, this shape would look like that, and this completed figure looks best like choice number 3. Number 7 says the volume of a triangular prism with a base dimensions of 4 centimeters and a height of 10 centimeters and a prism height of 15 centimeters is. Okay, so we want to look at what we're looking at. We're looking at the volume of a triangular prism. If you go to your reference sheet, you see a general prism is V equals big B times H. Big B right here is the area of your base. Right here, triangle is your base. So you're going to take big B and replace it with the area of a triangle, which is 1/2 base times height. Because this big B is the area of the base, and our base is a triangle. So now we're going to substitute in what we know. V, that's what we're trying to find. 1/2 is a constant. That little b is the base of your triangle, which is 4. The h is the height of your triangle, which is 10. And this h on the outside is the height of your prism, which is 15. So when you substitute it in, it should look like that. Type that all into your calculator, and you get 300 centimeters cubed, which is choice number 2. Oops. Okay, so number 8 says find the volume of the following 3-dimensional objects to the nearest hundredth. So this object on the left-hand side right here is a cylinder, and this object on the right-hand side over here is a cone. So the first thing that I want you to do is go to your reference sheet and locate the volume formula for both a cylinder and a cone. So your first step would be to write those formulas. We have, for a cylinder, V equals pi r squared times h, and for a cone, V is equal to 1/3 pi r squared h. The next thing that you want to do is look at your diagram here and substitute in what you know. This right here, your radius is equal to 4, because remember the radius goes from the center and meets that edge of the circumference. And your height is from one base down to the next base. So on the left-hand side, you're substituting in 4 squared for r and h for 10. And what you could do, since you have all these terms filled in, is just type it in your calculator and you get 502.6548 and round to the nearest hundredth. That means you're going to round to this position here, so you have to look at one after. 4 is less than 5, so that remains 502.65 centimeters cubed. Now on the right-hand side, the volume formula for a cone is 1/3 pi r squared times h, which we found on the reference sheet. 1/3 is a constant, bring it down. That pi is a constant, bring it down. R squared represents the radius. Here they gave you the diameter. The diameter goes from one end of the circle to the other end. It's the full length from one end to the other. So the radius is always half of that. So your radius here is 6. So 1/3 6 squared times height, which is from the base of this circle all the way up to that vertex. That length right there is 4, as you could see right there. So we're substituting in 4. Type that into your calculator. Same thing, you get 150.79. You're looking at that third number after the decimal place. The 6 is greater than 5, so we round up. The next hundredth position becomes an 80, so it's 150.80 centimeters cubed. And the last question, number 9. Find the volume of a square pyramid with base edges measuring 45 feet, an altitude of 68.4 feet, and a slant height of 72 feet. Whenever you're looking at a volume problem and you see slant height, make sure you cross it out so you don't get confused. Okay, so now we're looking at our volume. We're looking at a square pyramid. So go down to your reference sheet and go all the way down to the bottom, and you're going to see the volume formula for a pyramid. Volume formula for a pyramid is V equals 1/3 big B times H, where big B is the area of the base. Our base shape right here is a square. So our area of a square is side squared. We replace the big B, because big B means area of the base, with side square, which is this side times this side, or 45 squared. So now we're going to replace big B with side squared. And here, again, we cross that off. Our side is 45. This side is 45, because all sides of the square are the same. So we're trying to find this area, because that's what area of the bases means. And we're taking this area of the base, multiplying it by a height of 68.4 and multiplying it by 1/3. So substitute in everything that you know. 1/3, 45 squared, 68.4. And when you type that into your calculator, you're going to get volume is equal to 46,170 feet cubed. Okay, I hope this helped. If not, please come to Extra Help. I'll be there tomorrow morning. Come as early as 6:55, 7. Bye.